Hi there, Physics 131. So, as usual, I want to go through today's reading. So, Class 13, we're into Chapter 5 now. Okay, so this is about circular motion. And see, once again, like Chapter 4, they open this book with an image. They open the chapter with an image that doesn't match the caption. This is Kruti Patel, a civilian test pilot, wears a special flight suit. So, and then the picture is clearly of the Snowbirds, which is a Canadian, Royal Canadian Air Force aerobatics team. So I don't know what's going on with this. I feel like maybe they just changed the photos at the last minute and kept some old captions or something. It's the second time they've done that. But okay, so the question is, so they're talking about acceleration during circular motion. So test pilots then they go through a circular path. They're experiencing a huge amount of acceleration, and that can cause them to pass out. So that's kind of cool. And of course, what I really like about this book is that they start off with qualitative, like concepts, based on stuff that you can really kind of grasp, like hitting a bowling ball with a hammer or swinging a backpack around in a circle. And so these forces are discussed qualitatively. First, definitely recommend reading this. And then section 5.2 is where they start getting a little more mathematical. So it's called Analyzing the Velocity Change for Circular Motion. So here's actually an excellent question, is if you are in a car and you're got the same speed, but you're going around a corner, is this acceleration? So you're not speeding up or slowing down, because I can tell that because your speedometer is fixed right at whatever you're going, maybe 60 kilometers an hour. You stay at 60 going around that corner. So is it acceleration? Well, to find acceleration, you have to subtract final velocity minus initial velocity, and then divide by the time interval. So is this a zero vector, final velocity minus initial velocity? So the way you do it is, if you sort of zoom in a little here, you're going around the corner, final minus initial. If you actually do the vectors, you do get a delta V. It's not zero. So if you're turning to the left, you've got an upward delta V. And that's going to correspond to an acceleration, which is always towards the center of circular motion. So you really need to work through, I think, this physics toolbox and try to understand what the delta V is. But when you figure that out, it's really awesome, because the delta V is always, for any two little points on a circle, it's pointing towards the center of the circular path. So what we think is that as you're turning, you're always accelerating towards the center of the circular path if your speed is constant, if that makes sense. The constant speed, but there is an acceleration vector, so all the delta V's are always pointing towards the center. And I think in the next section, tomorrow, we're going to figure out how you quantitatively get those numbers. So that's it for now. It's just a quick little video, but definitely do the reading as usual.